All right, so we're continuing on our quest through related rates, and let me tell you that in past years, this has been a common question for my test, and it is one of the more missed questions on my test because people tend to stink at geometry. Yeah. And if you can understand some basic ratios, the geometry is not going to be hard on this. But again, if you're going through these processes, you guys, I think, are one of the brighter groups I've had, maybe perhaps the brightest group I've had as a senior class since I've taught this. So I think that you're going to be able to handle this kind of thing. It's not overly difficult. I think you will see that. But if you miss, again, remember we talked about yesterday how we want to minimize our variables by making some substitutions in certain cases so I don't get that extra rate in there? Well, a lot of times on this substitution, to minimize this length, width, height, whatever you want to call it, when I do that, I make a bad substitution and then everything goes south. Are you with me? If you get a bad substitution in there, your volumes equation's wrong, you don't get credit for that. Then the things they're looking for in your derivative is wrong, you don't get credit for that. And you're going to continue to lose points as it moves down this problem. Now, you might still get some for writing down the information you're reading, or for showing that you're making certain substitutions, but you really got to be careful on the substitution in a situation like this. So as we're reading this problem, it says you have this trough that's 12 feet long, 3 feet across. The ends are isosceles triangles with altitudes of 3 feet. So that means the actual ends of this, it said, hold on, with altitudes of 3 feet. Yeah, it's 3 feet across, and then the height would also be 3, right here. Right? And then it says, if water is being pumped in at 2 cubic feet per minute, how fast is the water level rising? Now, as you can probably tell, as the water gets pumped in, when there's nothing in there, it's going to start rising more quickly, right? Because it takes less volume to fill up that little bit than maybe it does to fill up or the first inch than it does the second inch or the third inch or the fourth inch. Are you with me? So the rate at which the water level rises is going to be slower as it moves towards the top because it's taking more water to fill it up. Are you with me? So let's just go through the process that I encourage you to kind of follow and see what happens. So right now, we're going to be dealing with what kind of situation with the question is, how fast is the water level rising? What am I asking you about? How fast is the water level rising? So I'm talking about the change in I think I'm really going to be talking. How fast is the water level?
Excuse me? The water level implies height. The water level is right there. You're measuring where it is like.
Okay, I am talking about height here. Yes, I started to second guess this, but when I'm talking about height, I got to get height. The rate of change in this height is what that's asking for, right? The dH/dt, and I'm asking for the rate of change of that height at what moment? When the h is 1 feet. So it has the capability of getting up to 3 feet before it pours over, right? But I want to know what it is at a height of, say, 1 feet. So I want the rate at which the height's changing at h equals 1, or when h equals 1. Now, the other information I have here is water is being pumped in. What is that talking about? Volume. So the rate at which water is getting pumped in is what? So how do I write that? dV dt is 2, and that would be feet cubed over minute if I was writing out the units. And is that positive or negative? Positive. Now sometimes you'll have a trough with a hole at the bottom and it's draining water out. In that case, you would say if it was leaving at 2 feet per minute cubed or whatever, then you would have a negative. Although that would not be true because as it leaves, it would be changing the rate if you think about it. Right? I can pump it in like out of a hose at a constant rate, but if I was draining it out, it would probably drain out more quickly at first because there's all this water pressure, and as it neared the bottom, it would probably slow down. Are you following me? Okay, so I have that information, and I also have all these lengths and widths and stuff like that. Now, what possible scenario here can I somehow include a volume with a height? What do you think I would need? A volume equation that includes a height in it? Now, do you know how to do a volume of something that has a cross section, a constant cross section all the way across?
The
area times the length, and that is always true. So if I have the same cross section, if I can slice it and I always have the same cross section, then it's area of the cross section times the height. That's true whether it's a trough, whether it is like a cylinder, right? If the cross section is the same, I can find that area times that height. That's even true if you have like something that does like this. If the cross section is the same, you would take the height of this thing times the base. And that would be true. Think of a stack of quarters, right? If I have a stack of quarters and I kind of push the edges in so they kind of, like I push them in like this, it's still the same volume, isn't it?
Correct.
Okay, so because I can do that here, I can find the area of this times the length. Now let's do it in terms of variables, okay? Because I want to be able to differentiate this thing and have rates with each of these variables that might change. Are y'all with me on that?
Yeah.
We talked about yesterday when we had the ladder, I used the X and the Y, and because the ladder didn't change, I put 25 in there. But I didn't put remember the X equals 7? I didn't put that in there before I took the derivative because it changed. Now on this particular thing, I've got what? If you're trying to find area of this triangle, what would you do? 1/2 base times height, so I'll call that the B, that the H. So the area of this triangle would be, if I'm finding volume, would be 1/2 base times height, right? And then how would you find the total volume? Times length, okay? So technically, that would be my volume equation. Now, when you think about this, my base of my trough is not changing. However, it's not really the base of the trough that I'm finding, is it? I'm finding the volume of water. So when I think about the volume of water, I'm talking about the height of the water and the base of the water. Are you with me?
Minus that.
So both of those are going to change, aren't they? As the water level rises. Is the length going to change?
No.
Then I don't need an L in there. I'm going to put a 12, and I'm going to simplify that. So that already makes my problem better. But you do not want to put 3 in there for your base, because what you're doing is measuring the change in the volume of the water. And the height and that width across right there are changing, right? That's a big deal that you start catching these things right here. But the length of the water is constantly 12 as it rises up. You tracking with me? Okay, now if I differentiate here, what is going to end up happening when I take the derivative? I'm going to somewhere have a dv/dt, a dB/dt, and a dH/dt. Now I certainly want the dH/dt in there because I'm looking to solve for that. And I'm fine with the dV/dt being in there, but I don't have a base, do I? So what I need to do is try to find a way to get rid of that base. Now some people go, well, I'm going to get rid of it later. I'm just going to take my derivative, it'll be a big product rule, and I'll have a first d second plus second d first, and I'll have a dV/dt and a dH/dt in there, and I'll worry about it later. That is an option. But I suggest you go ahead and replace that b, so you will never have a dV/dt in there in terms of h. So I want you to tell me, based on this picture, what do you know about the ratio between the base and the height? Just look at it.
Can you just use the first equation for the volume and put everything on the left side? So this is just 1, 2.
What do you mean put everything on the left
Like,
side?
base would
Oh,
be
you can totally resolve if you want.
2v over.
But you still are going to have a v and a b, right? And I'm trying to get rid of b. You can always solve for any variable you want. That's true. And if you choose to do that, that's fine. I normally take the derivative of what I see, because to me it just, most people tend to do that. But yes, at any point, if I go, hey, I'm solving for dH/dt, I'm going to go ahead and solve for h first. I mean, a lot of times that's going to put you in a quotient rule situation, but you totally can do that. And we'll look at that at the end. But I still have a b to deal with, right? So is there a relationship between B and H in this problem? Yeah. The ratio, triangles, guys, are always proportional. You beat the crap out of that in geometry, didn't you? Different triangle ratios if they were similar. And as my height rises, aren't these similar triangles? So can't I say the base and the height are always proportional? So if the base is 3, when the height is 3, I can say base is 3 and height is 3, and then I can solve for base and make a substitution. If this was 10 and the height was 3, I would say base is 10 when height is 3. Are you with me? I'm just setting up a proportion. It's not, but I would just set a proportion and then solve for what you want to get rid of and replace it for what you want to keep. So in this case, I have 3 over 3. If I cross multiply, I get 3b equals 3h, so b equals h. So it turns out they were growing at the same rate. So I'm going to now come over here, replace this b with an h, and my problem just got significantly more simple. Now what George was saying is, why don't we just solve for h here? Well, you tell me. And again, it is not a terrible idea. But if I were to do that here, I'm going to end up getting the square root of v over 6 is my h. And I'm going to have to take the derivative of that. Now that to me is not overly ugly. It's not. But I honestly, most of the time, I will just take the derivative of this, and then when I'm finished, I'll just solve for h. But you totally have that freedom to do that. Okay? I'm going to tell you, sometimes it might get uglier, sometimes it might be better. So that'll be up to you. I will look at your algebra either way. But at this point, you've done all this algebra just to get to the point where you now can take the derivatives. So what's the derivative of v? 1 dv dt. And what's the derivative of that? 12h dh dt. And then at this point, it's just a matter of plugging stuff in. Now, so the dv dt is a 2. The 12 stays. The height is at 1. And I solve for dh dt by saying dh dt equals 2 divided by 12, or 1/6. And what would the units be? The height was measured in feet, and the time was measured in, was it minutes?
Yes.
Minutes. So listen, there's nothing hard about the calculus of this at all. What's hard about this is the setup in it. Now for those of you, and there's always a rare person who likes to do this, they go, hey, I want to just stick with this. So they're going to keep the b in here. Now this is why I think this is harder, but you can see in the end, you're going to still end up getting the same value. If you keep it in there, you're going to have to do a product rule. So you're going to get dv dt equals first d second plus second d first. And then you're going to have you actually don't even have a b, right? So you're going to have to go back and still look at this ratio and go, oh, if h is 1, and you have to plug it into this ratio, you have to solve for b. And in this case, it's the same. But you're still going to need the ratio to be able to solve for that b value, but you could find it. And then the h we know is 1. That's a 6. And the dh dt I'm looking for, the dv dt is 2. So I'm going to leave the dh dt in there. But what do I also need? So I'm going to have to go back to the ratio again and say, all right, if b equals h, take the derivative of both sides, db dt, dh dt. Oh, they're the same. So I can replace db dt with dh dt, and now I can solve. But in no way did this really feel better to me. Did it to you? It seemed like so much extra work to work from the back end on these substitutions as opposed to being proactive on the front end and making the substitution, making your life simple. But you can still do it. What is 6 of those plus another 6 of those? 12 of those. And then when you divide by 12, there's your 1/6. So again, I strongly encourage you. A lot of the book keys do not make those substitutions ahead of time. They don't. But over the years, and I didn't used to teach that either. I used to say, okay, now that we've done this, let's go. And people are like, and people's grades were getting hammered. And since I started doing this, people have had a lot more success with it. And I'm not saying it's always better. Because sometimes when you make the substitution, it makes this really nasty. It does. But is it a whole lot nastier than this? Not much. So anyway, that's a trough problem. And guys, you can expect to not have the base and the height the same if you see other ones. So again, if they're different, just say base over height equals the given base over the given height, and then just solve for whatever you need. Be careful about your cross multiplying. It's just a simple proportion, but for some reason that crushes people right at the beginning. Also, they leave the length in there. So then if they leave the length in there, now they got a really ugly product rule. Or they put the 12 in, but they also put the 3 in and the 3 in. I get this all the time. Volume equals 1/2 base times height times length. And they go, all right, the length's 12, the height's 3, the base is 3. Sweet, there's my volume. Great, and if I had asked you for the volume of the trough, that would be awesome. But I wanted the dVdt, or even worse, dVdt is 0. Right? And it's just not a good happy face. Right? So make sure you don't put those substitutions. You can't do that. Can't do that because those things were changing. That you can. So I think over time you'll get this. But keep in mind, you only have today, Thursday, Friday, for more practice in here and whatever you happen to do at home. You've got to be doing these and catching these errors so you don't make those mistakes on test day. All right, check out let's move on. All right, here's a cylinder problem. It says, through the miracle of illusion, Penn and Teller make it appear as if a cylinder is changing size. The rate of change of the volume of the cylinder, so imagine a cylinder, all right? The rate of change of the volume of the cylinder is increasing at a rate of 4 cubic meters per hour. So what did they just give you? I gave you dVdt is 4. So I got that. And then it says, if the height of the cylinder is fixed at 2 meters. Now that's a big deal, right? Height is fixed at 2. So when I come up with this volume equation at some point, I don't have to leave h in there as part of the derivative. I can replace it because it's fixed. All right? Then determine the rate at which the radius of the cylinder is changing. What did I just say there? dr dt. So I don't know that. I'm determining that, but when? At r equal 3. So at the moment when the radius is 3. So I know the rate of change of the volume. The height is fixed. I'm looking for the rate of change of the radius when the radius is 3. Okay? So what do I know about volume of a cylinder? And literally just talk about that. Pi r squared h. So I've got this r right here, and I've got this h, but the h is always 2. So when I start out with volume, which is pi r squared height, if my height is always 2, I can plug that in before I differentiate. If you don't, what happens?
You get 2.
I end up doing a product rule, and I end up with the dH/dt in there. Now, ironically, when you end up with that dH/dt, you could say, well, what is the rate of change of the height? 0, because it's not changing. So I guess you could put a 0 in there later, but in the meantime, you've had to waste all this time on the product rule. So don't do that to yourself. Once you make your substitution, that 2 times the pi is out front, and all I have to do is say, all right, dV/dt. Oh, and by the way, I'm looking for dr dt. So if you wanted to solve for r, you could, but to me, solving for r requires me to have a square root function with a bunch of junk in it. I'd rather just not deal with that. So I'm going to take the derivative now, and I get 4 pi r, what? dr dt. And at this point, I'm home free, right? dV dt is 4. My radius is 3. I'm looking for dr dt. So everything works out nicely. So when I divide by a 4 pi 3, what ends up happening to dr dt? 1 over 3 pi?
Yeah.
Right? Because when I divide both sides by a 4 pi 3, the 4's cancel, but the 3 and the pi are down the bottom. And what would be those units? Yeah, the radius is meters, and so that would be meters, and then the rate of change of time would be dollars. Now look at the next thing. Part B says, same kind of situation, but this time it says, assume the volume is fixed at 20 cubic meters, and the radius and the height are changing. So in this case, I'm looking back at this volume equation. It said assume the volume is fixed, so I can go ahead and plug a 20 in there. Right? You with me? Because it's fixed. But the radius and the height are changing. It says determine the rate at which the height is changing. So what is that asking for? Determine dH dt. At the moment, the rate of change of the radius is 2 meters per second. So at the moment, what? dr dt equals 2, and what? And the r equals 2 as well. So all of this stuff now is kind of obsolete from before. Not a lot of carryover because they changed the problem so much. But again, at this point, if I take the rate, I'm going to have a what? A dr dt and a dH dt. Am I okay with that? Yeah, I have one. I'm looking for the other. So I jump in there. What's the, when I ddt to the 20, what do I get?
0.
And by the way, on this one, since you're looking for dH dt, again, you might want to solve for h. You don't even have a square root. Now you are going to end up with a quotient rule that you have to deal with a little bit, which is not awful. But again, I don't mind it like this. So I'm going to take the derivative of that and get a 0. And then how would I take the derivative of this? Product. So first, d second, dH dt, plus second, d first. And what's the d first there? 2 pi r dr dt. And then at this point, you're solving for that single dH dt right here. So I'm going to plug everything and then start moving it over. So what's the r value? 2, so 2 squared is 4. And what's the h value? You can solve for that, but you know how to do that, right? If it's a quantity, where would you be plugging it in, plugging something in to solve for h? Back in that, right? So if I know the radius is 2, I can say, hey, when r is 2, I can just plug that in there and out to the side. So I end up with pi 4h. So h is 5 over pi. It's not pretty, but it's fine, right? So I plug the h in. The 2 pi, the radius is still 2, and the dr dt is also 2. You with me? So what do I end up with over here? Pi's cancel. 40. So I'm going to subtract 40. And I get 4 pi dH dt. And divide by 4 pi. And what happens? Negative 10 over pi. And what would that rate be? Meters per hour again. Now, why do you think my height's changing?
Because it's evolution.
That was a terrible question, not what I meant to ask, but yes, perhaps. Why is my height negative?
Because the radius is increasing, so for the line becomes.
Y'all see that? So that should make sense. If you have a cylinder, if the radius is getting bigger and the volume is not changing, what would have to happen to compensate for that? The height would have to shrink, right? So that does actually make sense in this case, but anytime you get something like that, do think about it, because most of you guys, all of you guys, I think, can handle that thought and go, well, that makes sense. If I have a fixed volume and the R is getting bigger because the R is changing positively, the R is getting bigger, the height would have to shrink to make things keep constant volume. So that kind of checks out for me. All right. What about, I got another trough problem, but you know what? I'm going to go, since we just did one, I'm going to go back and look at
For B over
the cone problem. I'm gonna get my key to make sure I don't mess you up. Plus, I always think of Mr. Humphrey on this problem because he loves to say the word conical pile. Because that just makes me happy when I say conical pile. Like if you see him today, say, hey, we did a conical pile. He's like, we'll get kind of excited. Okay, so out of sand and gravel plant, sand is falling off a conveyor and onto a conical pile. Okay? So imagine there's some conveyor belt, somebody's throwing sand about it's coming up here like this, and it's just falling off the tip of it, coming down like an hourglass. You know, and the sand is just lining and making a bigger and bigger pile. So if it's a cone, it's falling onto that cone is growing, right? As it grows, it hits the bottom, it just starts growing bigger and bigger and bigger. So anyway, it says it's falling up onto a conical pile at a rate of 10 cubic feet per minute. So what is that? The rate of change of the volume. Don't go d-sand, dt. That's not going to help you, right? You got to think in terms of what's actually happening. I see people do that, d-sand, dt, or d-water, dt. It's its volume, and there's the hint, cubic feet, right? So it's the change in the volume. dV dt is 10. Now, by the way, if it said sand was leaving the conveyor or leaving something, if it's emptying out of something, then it would be a negative 10. But since it's piling up, it's increasing, it's a positive 10. It says the diameter of the base of the cone. So here's kind of a cone right here, right? So sand is like trickling onto there and making this. It says the diameter of the base of the cone, so this is D, is approximately 3 times the altitude. So this is A. So what's the relationship? The diameter is 3 times altitude, or height, if you want to call it height. Are y'all with me? So that's a proportion, in a sense, right? That's a way I can make a substitution if I need it. At what rate is the height of the pile? And height would be the what? I tell you what, let's just make that h. So 3d is 3h. The height of the pile changing. So what is that saying? What rate is the height?
dHdt.
So what is the dH dt? Question mark. When what? H is 15. So we're going to need the volume of this cone. I don't expect you to have that memorized. So volume of a cone. I think it's 1/3 pi squared h, but I forget it too. Yes, 1/3 pi squared h. That's something that I would give you. So the volume of a cone is 1/3 pi r squared height. Now, I have dV dt. I'm great with that. I'm looking for dH dt. I'm great with that. But I do not know r. In fact, I wasn't even given r.
R is 1/2 D.
Now, r is half the d, right? So could I make a substitution there? And say diameter is the same thing as what? 2r, right? Don't put 1/2 r in there, right? So diameter is the same thing as 2 r's, and that is a substitution. That is your new proportion. So if I'm trying to get rid of r, what do I want to replace r with?
3/2 h.
Now, this is the kind of thing that makes people miss these questions. It's not the calculus. And that's true for probably 75% of calculus. It's the algebra, it's the geometry, it's those little things. So I'm going to replace r with 3h over 2, or 3/2 h. And I'm going to simplify all this. And be careful when you simplify. So what do I end up getting? 9/4 times 1/3 is 3/4 pi h cubed. Take your time on that if you need to, right? I got 2 3's on the top, 1 3 and 2 2's on the bottom. 3's cancel, 3/4. Now at this point, I think I'm ready to go. So derivative of the left, dV dt, and guys, show your steps. Don't just put the 10 in there knowing that that's going to happen, because remember, you're getting points based on your showing your stuff. So dV dt equals what? 9/4 pi h squared dh dt. So you get a point for that, so don't shortchange yourself by putting a 10 in too quickly. You never know what the readers are doing. Plus, if you make a mistake, at least at this point they go, oh, we can see that derivative, yada, yada, yada. Then plug in 10 equals 9/4 pi, what's the height? 15, square that, 225, and you're looking for the dh dt. So at this point, and guys, don't make this hard, this is just algebra, right? How do you get rid of a 9/4? Multiply by 4 9s, gone. How do you get rid of a 225? Divide by a 225. How do you get rid of a pi? Divide by a pi. And then you could just come over here and go, oh, that's 4 times 10. If you can simplify stuff, go ahead. 4 times 10 would be a 40. Actually, you know what? I can cancel a 5 out of that, might make my life easier. 5 out of that's 2. 5 out of that's 45. And then I could go 8 over 9 times that's what? 405 pi?
Yeah.
Let's just go with it. And then the height is doing what? Changing positively, that matches up. And how would I write dh dt? Feet per minute. And you may look at that and go, well, that's a terrible answer. What does that even mean? Well, type in your calculator to make more sense, but that's not a very big number. So if you ended up with a really ugly decimal there, if you had a calculator, that would totally be fine. I think the decimal does end up being like 0.00628. So it is pretty small. So if you had a calculator and you just typed it in there, you would just have gone 4 times 10 divided by, in parentheses, 9 times 225 times pi, and you would have gotten a tiny decimal. Not too bad?
Not too bad.
Child's play?
Child's play.
Anybody got any questions on any of these homework problems we've looked at?
Yeah.
He was wrong.
You
It
do.
was the wrong problem.
It was the wrong problem?
Wrong problem, it was, you had the key for number 20 in that page, but the
I'll go back and
assignment
look.
said 27.
Key.
Oh, wrong day, I'm bad.
I remember yours.
So y'all did it right, you were, I'm good?
Yeah.
Good. I may be wrong. So anybody, hey guys, anybody have a question on any of the homework from last night? We got a little time,
Oh, I have a question for like a couple nights ago.
okay?
1973 AB number 3, part C.
Is it in the book?
Yeah.
Page what?
Oh my goodness. 46. 46 part C. Yeah, that's it.
Okay, so it says, find an expression, yeah, don't forget to go back and look at this stuff. Every year people get so pumped about the related rates, they're like, man, I got this related rates down. And they pull the test up and they're like, what? And they see all this stuff from implicit and parallel and tangent, and they like, my brain overheats. So make sure you review that before your test on Monday, right? Okay, so it says find an expression for the slope of the curve at any point on the curve. So bottom line, you're doing what? Taking the derivative and solving for dy dt. I mean dy dx. Right? So the slope is changing y over changing x, and dy dx. If you don't know this yet, dy dx, a dy is probably as close to saying change in y over change in x as you can say with calculus. All right, so when you see that, it'll make a lot more sense when we get to integration, because integration is finding area under a curve as opposed to slope of a curve. It's going backwards from a derivative back to a function, but it's essentially what it's finding. And to find area of really weird curves, the way we think about it is really skinny rectangles in there. And we're going to be finding the height times the width, and the width is the change in the x. So you're going to see that kind of mentality change in, or little bitty tiny particle, whatever, that's what slope is. But anyway, so when I take the derivative of this, what do I get? 1 dx dx, which I can ignore, plus
product from
first d second plus second d first.
Right.
Plus
4y dy dx.
4y dy dx equals a 0. And it's not always 0, although you see that a lot on these problems. I could have a 6x minus 3 or a 7y minus 4. I could have anything over there as well. So what am I moving?
You're moving the things without the move dx.
So get rid of that 1. Get rid of that y.
And then divide it with
Factor out the dy dx, which would leave me an x plus 4y. And I'm going to divide by an x plus 4y, whatever I had over there. I don't really see anything simple, how it simplifies. And again, in 1973, when I was 6, that's what they would have done and left it. Okay? Yeah, some of your parents might not have even been born. Anybody got young parents in here, like 45, 46?
My parents were born in 73.
Really? Yeah, my wife was born. Yeah, so what month?
My mom was born in July, my dad was born in October.
Not even born. May.
Oh yeah, my dad was born in February.
February? Alright, so he was alive. Just pooping all over the place and stuff, and that's... Anyway, long time ago, and the reason why you see me using these again is they don't ask 9-point problems like this. What you could probably expect is find an expression for the slope, and then there would be multiple choice with a whole bunch of stuff that looked a whole lot like this, but maybe a sign different here or there. So, alright, so that's 3 points back in 19 whatever. Probably. Okay? Part B, write an equation for the line tangent to the curve at 2, 1. Now, if it's tangent to the curve at a point, and this is the slope, what would I need?
plug in the point.
A point and a slope, right? So how do I say, and by the way, remember this is going to be in part A, so all you would need to write on your paper is what? You don't need that. You need to say dy dx what? At 2, 1 is, and then show you plugging it in. But don't say dy dx and plug it in, because the slope isn't when that's a 1 and that's a 2 and that's a 1. The slope at 2, 1 is that. So you have to learn to label. It's kind of like this. If I'm trying to find f of 2, I don't write f of x is and then plug 2 in everywhere, do I?
No.
I write f of 2 is. Same thing here. You got to say what you're doing and then plug a 2 in for the x and a 1 in for the y. So -1 minus 1, 2 plus 4 times 1. So -2 over 6, -1/3. Now that I have the slope, what do I do?
Right in front of it, you know.
So the equation of the tangent line. So therefore, y minus this 1 equals slope, x minus that 2.
Right.
And this would have been, honestly, at this point, probably the easiest AP question I've ever seen in my life, because these were 9 pointers. So this would have been probably another 3 points. You probably would have got a point for showing that you wanted to find the slope there, a point for plugging stuff in, and maybe a point for knowing it's a line. I don't know. Pretty easy here. Back in 1973, they would have made up for it by some really brutal algebra problems that would have killed you, or brought you near to pain and suffering. Find the coordinates of all the other points on the curve with the slope equal to the slope at 2, 1. So how do I find the point, all the other points on the curve that had a slope equal to -1/3?
Just said dy dx equals -1/3.
So dy dx equals -1/3, right, would give me an equation that relates y's and x's. Now at first glance you're like, how is this going to be kind to me? And this is the kind of thing, and that's all I would have started this problem out with. Part C, this is the kind of thing that you're probably not going to see before, because my guess is there's probably some clever factoring involved, but I don't even know that, I'm just guessing. So cross multiplying, -3y minus 3, cross multiplying, I'm going to leave the negative with that, -x minus 4y. Actually, in this case, I still have an x and a y, so I'm going to hope that when I move this all on one side, something pretty happens, but it may not. Adding a 4y. Okay, so this is what happens. When I add a 4y, I get y. I'm just going to move that 3 over and see if I could find what happens. So it says, find the coordinates of all of the points on this curve with the slope equal to the slope at 2, 1. So what I would do is I have basically a relationship that looks like a line, right? If I want to find all the points on the curve that meet these conditions, and those conditions, what do you think I ought to do? Solve a system. All right, I don't know what this looks like. Maybe it looks like this, right? But I do know what that looks like. It's some line with a negative slope. So if I just solve this system, I can find the places where it intersects. Are you with me?
Yeah.
So that's all I'm doing. It'd be really great if I got y equals 2. And then I just plug a 2 in for y and solve. Sometimes it's not that kind. So, and this is actually more along the lines of what AP would do to you. So I'm going to take that and plug y, I'm going to plug that in for my y's. Okay? And to me, I think that's a better idea, but technically you could solve for x and plug it in there if you wanted to. 6 of one, half dozen of the other. So right there, plugging a y in, I would get x plus, and that, by the way, I would not show work there and then come back over here and make it confusing, unless maybe I drew some arrows or whatever, times the y plus 2 times the y squared equals 6. So let's clean this up. X minus x squared plus 3x. That's going to give me what? X squared minus 6x plus 9 times a 2. So plus 2x squared minus 12x plus 18 equals 6. Let's clean it all up. That gives me an x squared. That gives me a negative 8x. And that gives me a 12. Oh, how nice of them. So when x is 6 and x is 2, these are going to be 2 more places, but how would I find the points?
Well, don't you already have the 2, 1?
I already have the 2, 1, which you'll find out in a second. But I can plug 6 back in what? The original equation or this one?
Out.
Either one, because you're finding it. So I'd plug it in that one. So if I plug a 2 in there, you can see that I get 1, which I've already have. If I plug a 6 in there, you see I get negative 3. So there was one other place. Now, the reason I think AP doesn't ask a lot of this anymore is not a lot of calculus involved in that, is it? I mean, to recognize that that was equal to that, that's the only calculus. Everything else after that is algebra. And they, I think at some point, realized, why are we making this an algebra test? So they test a whole lot more calculus. They'll probably ask this question somehow to see if you understand that's what you would do, but they're not going to make it a 3-point question that requires all this much algebra. They just cut way back on that over the past 47 years. All right? How we feeling? All right. Guys, keep up that homework at the very minimum. At the very minimum. Look at these problems. I understand. I get it. I don't like homework. But at the very minimum, get yourself familiar with these word problems. Look at them. See if you would be like, oh yeah, I would have found that. I would have found that. I would have understood how to do a ratio of certain kinds of triangles. Make sure you're familiar with that stuff so you don't have any surprises on your test.